Store, then here it is. Component Store. Actually, I'll start with about myself. So yeah, if you've been to any of the Angular archives before, I was lucky to be presenting there both remotely once and last year even in person. So it was very exciting. Actually, I grew up in Kharkiv and moved to Canada 15 years ago now. So right now I'm part of a Firebase team. I work on the console. Hopefully many of you are familiar with Firebase and using it. I'm also part of the NgRx team. I organize Angular Toronto meetup here in Canada, which we just had actually second remote session in July. So if you missed that, I'll be uploading videos for that soon. And I'm very proud to be part of a in-depth dev group of people who are outputting a fantastic content on the in-depth dev. It's probably one of the most advanced Angular content out there. It used to be called Angular in-depth, so now it's in-depth.dev because it covers more than just Angular. It covers some of the other frameworks as well. So if you're not subscribed to that, you're missing out. Okay, so what is ComponentStore? ComponentStore is a state management library. Or you might say, hey, hold on, doesn't NgRx already have a state management library? Well, in fact, it does. And actually, a lot of the NgRx branded libraries now are almost known for its global state management library, which is, in fact, now NgRx is still a brand, which is Angular Reactive, Reactive Angular. And then there are some libraries like Global Store, now ComponentStore, this component as well, and others as well that are coming in the future. Maybe a router, we'll see how that goes. So NgRx is a brand of libraries that are reactive. All right, so the state management library, and so that's the second state management library, right? And what is this? It's state. It has a state and it manages it. But before we dig deep into this, what is state? What is it that we're working with? Why do we need to manage it at all? Well, there are multiple ways of describing what the state is. I'll show you the one that I first saw Victor Sufkin do, and I liked it and I adopted it for my things as well, because I think they kind of make sense to me. So we have a server or backend state. This is the source of truth of our applications. This is where we persist our data. This is where we store it. And whenever our web app requests something, we get a snapshot of that. So in the web app, we have more than just single state. We have a persisted state. We have URL state, client state, local UI state, and there are actually others, but they're basically less relevant to the topic of today. Okay, so let's look at these four. So what is a persisted state? Persisted state is actually the state that we are persisting from a backend. So this is a snapshot of data that's coming from the backend, and this is the data that is also going to the backend, right? So this is a persistent state, something that we trying to synchronize our front-end application with the backend. This is a persistent state. URL state, it probably is a little bit clear what it is. It's basically the state of a URL itself. Sometimes it also router is included into this, or router data into this, but it's fairly straightforward. It sets up where our application would navigate, which basically trickles down, and then which data we need and all that stuff. So URL state. Then we have client state as well. Client state is the state of the application that is not persisted to the backend. So backend does not need to know which tab is currently open. URL knows about it. Moreover, we synchronize our URL with this one, and it becomes highlighted. So this application knows about this through URL, for example, in this case. but it's not persisted to the backend. Backend doesn't know or care which tab is open right now. So this is part of the client application state. And then there is also a local UI state. For example, the state of this enabled button. The button itself has the state inside. Is it on or off? That's all it cares about. It does not care about if it's tied to any application state outside. It's basically talking through inputs, outputs. It's very local to that component. It could be tied in the end to the persisted state. For example, if our email provider for authentication is in fact enabled, it would turn it on. But it's for the button itself, it doesn't care, right? It only knows that it has this enable boolean that it's on and off. So it's like presentational component. So this is a local UI state. And that local UI state can be actually at different levels of this application tree. All right, so these are the 4 states that we kind of have. And actually synchronizing all of these states, making sure that it's sync, making sure that when we do requests, we wait for things. How do we load? Do we show a loading indicator or not? How do we handle errors? Synchronizing all of these states is one of the most complex tasks that we as front-end developers have. And this is basically solving these problems is what we're getting paid for. So these are the most tasks that we need to solve. And this is what the state is. And this is what we're trying to manage in the end. So how is ComponentStore managing the state? Well, just like as any state management thing, we need 3 things. We need a way to read the data. We need a way to write the data, right? And we need to somehow organize our side effects. And if you are familiar with NgRx store, we have create selector for reading the state, create reducer for writing the state, for updating the state, and create side effects for creating some of the side effects, like handling some of the race conditions or any other basically API calls that would affect our global state. In the NgRx component store, we have a similar methods for it. So we read the data with select. We write the data with updater to this local container of state. And we handle side effects with the effect. So you can see there's a similarity in the APIs because the problems that they're solving, although are different in scale and approaches, are kind of still state managing. There are some other APIs in the component store. Some of them are completely protected within the component store, so can be used. But I'm not going to be covering those today unless you have specific questions about them at the end. So let's see how we would use some of these APIs and how we would write our component store. So component store is responsible for a particular state, the one in an application. For example, here, our state would be an author state. It would have ID, name, maybe a list of book IDs that this author wrote, and the status of it, like is it a loading error or is that unsaved, and all of those. So this is the interface that describes the state. Then we would create a service called here, for example, author store, that would extend component store and would provide that interface of our state as a generic to this component store. So component store itself, it provides us with the tools, those select, update, affect things. And you can think of a component store as just a simple service with a behavior subject underneath. At least this is what it's trying to replace. And this is where it's trying to organize a little bit more, where we're currently creating our own behavior services with behavior subject, because many of them have some flaws. So we're trying to address all of them and organize them in one place. All right, so then in the constructor, we have some service that we inject, pretty straightforward. And the super is we can provide the initial state for our component store. We can provide it in a super call, or we can later on initialize it lazily if we want to. And again, I don't have an example of lazy initialization here, but I do have them in our NgRx docs right now. Okay, so we can initialize the state. So the first thing we'll then do, I'll show you how to read. It's the simplest one. So for example, we're reading it through the select method that comes in the component store. And select, we'll have a state, and we'll select just the name out of it. For example, you remember it has ID, name, and other things in it. So this will return us an observable of string of names. So what it becomes actually is a push-based service. So whenever something changes the name, it doesn't matter what it is, this name will always get updated. Okay, so this returns as an observable of name. And moreover, this observable also internally is distinct until change. So if the name doesn't change, you're not getting the new values of this observable. And it's also shared. So you can use this name now in your component in multiple places, and it won't be resubscribing every time. So it's all fine. All right, let's see example how we would use it. So in our author component, we would do a few things. So in order to use our author store, we would specify it in our providers there. So you see providers author store. And by specifying it in the providers, we're now tying the author store to the life cycle of our author component. What does it mean? It means that when author component store is destroyed, you navigate away from it. The entire author store will, first of all, unsubscribe from all of those names and further things that we'll have in it, and it will auto-cleaned up. So you don't need to clean it up by yourself anymore. So it's automatically cleaned up. And every time you connect back to the author component, like render it again, it will go through the same initial process. Okay, and then in the constructor, we need to inject our author store. And again, we do it the same typical way. Provide read-only and author store. All right, now we can pull this name and start listening for this in our component. So we do read-only name, and now we can use it in our templates. All right, so this is how we select things. And notice I didn't put any distinct, take untils here, or I'm not unsubscribing from the name at all. When author component is destroyed, our author store is destroyed, and within it, there are mechanisms that also take until and destroy everything you need. So you are avoiding those memory leaks. Awesome. All right, so this was the read. Now, how do we update the state? We update the state with the updater method. Well, one of them is updater method. And the way updater method works is it describes the how. How do we change the state when we, for example, this is an update status. How do we change the state when we get the new status? So we take the previous state of author state, and we take the status, and then we will spread the previous state, and we'll replace the status property with the new one. So the updater describes how. And this update status is actually now a method. So you can see there in the bottom, there's this update status to loading. So this will internally set the status to loading, or there's the last line there is update status to loaded. So it would push the loaded value, and this now becomes part of our state. All right. So this is how we update things. Let's move to the final piece of this API that we'll go over today, is the effect. Effect is such an important piece that I can't even describe how important it is. This is one of the things that are very typically missing in this service with the behavior subject approach. And what are we missing? Like this get author, for example, will do the API call to the author service to get the new author. And very frequently when we do implement our services ourselves, what we would do, we would have a method, right? That method calls the service, and maybe as a callback, you set that value to the behavior subject. So now you have the author data in there. The problem is with that approach is that you never handle the race conditions. And handling race conditions is one of the also quite important parts. So let's take a look again in this effect. First of all, it takes IDs observable. So, and again, explains the how we deal with this. So we have this IDs observable, and we pipe them. So one of the first things we'll do, like a filter, then we can update the status to loading, right? And now this is the place where we would handle our race condition, and we can choose this flattening operators. For example, here we're using a switch map. We could have been using merge map, exhaust map, or concat map. All four of them do completely different things. And it's very important because as you remember, this ID observable takes new IDs, right? So every time the author get author is called with the new ID, they're pushed into this IDs observable. And if we're already working on one of the requests, what do we do now? Do we wait for it? Do we cancel it? Do we cancel a request for the new ID, or do we start it in parallel? This is all the decisions you can make. And this is one of the great things about the NgRx effects, the global state one, and it's here as well. So you can really handle your race conditions and choose your flattening strategy correctly. Okay, so this one is switch map, which means if the new ID comes in, if I was already trying to get an author by a specific ID, I'll stop that request, drop it, and I'll start the new one. So, okay, so we get the result, and then we'll pipe that result. So we'll tap, and we'll do a few things. First of all, we'll call another updater, which is a set author. It will set the author data in our local state. And then we'll also update the status to load it that you saw already. And lastly, we will handle the error. So if we do have an error, right now we just updated the status to an error, some generic one. And we'll also catch an error just in case and push the empty. If we don't catch the error, our effect on error will just work once and then stop working. This is nothing to do with NgRx or ComponentStore or anything. This is how RxJS works. All right, so we have this get author effect. Let's see how we can use it now. One of the examples how we can use it is, for example, get an input. So we have an input of ID, and this input takes an author ID. Notice here it's string or undefined. It's not an observable. We'll just take an ID. And what we do here is we'll call this author store get author, and we'll pass this ID. And again, every time you call this get author, or if we have this ID, its input rebind to some other new value all of a sudden, we would do this get author call, and it would push this new ID into the observable of IDs, right? So this is what it does underneath. This is quite an interesting approach, I find. Well, I'm very biased about it, but this is the way we can really combine our imperative code, like inputs. We don't have inputs that are observables, right? So this is imperative, or the callbacks from our methods. Those are just still imperative. We call a method on our component. And this is the way you can really tie the imperative approach with the reactive component store. So it's completely reactive, right? And we can handle everything we need that way. All right, so those were like some of the APIs. So how is it different from the global store? Well, let's see. So I'll do some comparison with global store. I have a more descriptive, I guess, comparison in the docs as well, just because I know that this will be a very frequent question. All right, so the NgRx store has selectors, reducers, effects, and all that. And what's interesting, they are all living in separate files. Why is it done? Because the global store, the scale of it is quite different. We're working with a global shared state of the application. We need to handle multiple things happening at the same time, and it's solving the different kind of problem that what we're trying to solve with the component store. So those are all different separate files, and they can grow as much as they want to, and you can split it further into more files if you want to. Component store, on the other hand, it's all in a single file. So all the selectors, updaters, and effect, anything that can affect that particular state that this component store took responsibility on, it has to be kind of in a single file. There are some exceptions with additional selectors, but I won't cover this today, I guess, unless we get some questions about this. But I tried to cover it in the docs as well. But that's quite important because that also means that the state that this component is taking on has to be relatively small, right? Because otherwise this file just grows out of proportions and becomes too huge to manage. All right, so the other big difference, major difference is in the NgRx store, the entire state is in a single file. It's split by reducers that each take their own slice that they're responsible for. But in the end, this is just one giant object of a single state. That's why we have these actions that, used to transfer the data around. In the component store, we don't have actions. We don't have any actions, so we lose that indirection. But what we gain instead is we have multiple independent states. And those independent states, it becomes more important to work with them correctly, I guess, because you can really run into a problem very fast. But on the other hand, those are independent states, okay? And yes, okay, good. And one other quite an important difference, as I kind of mentioned before, in the NgRx store, the state is like forever, for a lifetime of your application. Until your application runs, you have that state inside it. On the component store, it's tied to the containing component. So that when that gets destroyed, the state gets destroyed. Okay. So when should we use component store, right? Where is it good for? We'll go through 4 examples. 2, I'll go into details. So the first one is a complex independent component state. Then it'll be a shared component state, reactive local UI, and I provided in root. We'll touch on it as well a little bit. So let's start with the complex independent component state. What do I mean by that? Yeah, this is what we'll start with. So say we have an app component that has a few pages. One of those pages has a component that's kind of nested. And the component A, it's pretty complex, but it has the state that it owns only within that component. It has APIs to talk to the backend with, and it basically owns the state. That state does not need to be known anywhere in the application other than within the component A. So what we can do is we can tie the component store to the component A, and then components like B, C, and D can use it if they want to, or you can pass some of their inputs. And then this basically, it manages that part of the state. It's very important, though, to note that component A should really, really own that state and not be sharing it anywhere outside of it. Right? It can take other data in, but not sharing the state out. And to solidify this one, I'll use the actual example of the application. I'll use the Firebase Authentication as an example. I'm working on this stuff, so I hopefully can explain it better. So we have different things that we work with Firebase, like authentication, database storage, and all of those open their corresponding pages. But those pages are fairly independent from each other. Like authentication doesn't share much, actually nothing with database or storage. They all share some information inside, like user permissions and all that. But within authentication, it's not sharing anything there. So let's look at this authentication page. So we have multiple ways we can authenticate using Firebase, and those are called providers. We can have, let's look at them. We can have like email password provider, right? So this is a provider component. If we click on Google here or phone, there'll be a second provider. It's like a phone provider, which again will pop up with this menu where you can enable or whatever you want to do with this. We have a third-party auth providers like Google or Twitter or anything like that. So there's multiple providers that you can manage authentication with, right? And your users can authenticate with. So those are all provider components within our application tree. They are contained by other things, right? They are contained by actually this thing. It's called identity providers. So it will contain all of the list of those providers, and we'll talk to them, right? Pass some of the data in and do other things. And again, this is, of course, extremely oversimplified tree structure, but I'm just trying to get the message across. So these identity providers are in a sign-in tab, which is a providers tab. It has some quota underneath. It has some other things as well. But this is, our component tree starts to grow. And of course, the entire authentication is a little bit bigger. It's like all of this, and it has other things like it has like users tab, it has templates tab, it has different kind of things there as well. So it has some other tables and other things. All right, and all of it is contained in this authentication index page, for example. So the APIs that we have to control authentication are actually fairly not as granular, let's say it this way. For example, when we do API, we get some kind of config back. And that config contains some of the providers, contains some of the user information, it contains some of the templates information. So it basically is not very granular, so it transfers a big chunk of things. That means that information has to be shared throughout all of these tabs. So what we ended up doing is creating something like authentication config store. And then the data that it has will be shared with multiple things, with users table, templates tab, quota, providers, and all of this. So those are basically selecting some of the data that we get back from that API call. All right, so, and then again, this auth config store is tied to this particular page, auth index page. So if we go to the database or to the storage page, all of this will be destroyed and it won't be part of our application. So it's not somewhere in the memory there. All right, one more other interesting thing is we can have multiple stores, even at the same level. So for example, this auth index page has also another store that attached to it, but it keeps a completely separate data that's not relevant to the configs. It's one of the like onboarding store. So it's like, did the user onboard already, or do we need to show like the welcome page and other things to it? And that one, for example, maybe only index page is using. All right, so this is a complex independent component state. The second example is the shared common component state. And this is actually was such a big typical problem with NgRx store when we were trying to use those common shared components with the data from the global store. It was very hard to do because you needed to have some kind of data that is in multiple components, but those components don't share it through the application. So we basically had to index it by a specific index within the global state. So the whole thing was a little bit awkward, to say the least. And it was definitely abusing the global store. So let's take a look at the problem itself. So we have an app component again. We have multiple pages. And then, those pages have specific components inside of them. But then we have a specific component that is very common or shareable throughout. And that component, common component, interacts with its parent component, like here component A or component C, through inputs and outputs, right? So this is how it consumes data, and within it, it can do some of the API calls even, but it doesn't need to share anything with the rest of the application. If it shares something, it does the output, right? And all the information it needs, it goes through input or maybe some of the API calls directly. And then, so what we end up doing, instead of pushing this data into the global store, which actually had no place to be there, it's not needed anywhere outside of that component, we ended up creating a component store for it. And this was how ComponentStore was actually born within Firebase console at the end of last November. So this was one of the first use cases for it. All right. Hope it gets clearer. One other use case is reactive local UI state. And we already saw the button, for example, enable. And here, where it gets a little bit more interesting, reactive local UI state is, sometimes people try to make it reactive so it works with on-push change detection strategy. However, what's interesting is change detection still works with on-push components that have an event that originates from them or from their children, right? So you don't always need to tell a change detector ref that, mark, check me, or detect changes. If event originates from the component, somebody clicked it, it would still be checked. So it would be checked with the zones. So when we have zones, it would be still fine. And of course, in the zoneless case, that won't be the case. So you still have to explicitly say, because in the zoneless case, nothing is patching those events. So it doesn't know that it needs to run change detection. So if you're working with the zoneless applications, or if you need a local UI state that's actually reactive, the component store could be a really good use case for this too. I don't have a particular example for it, but again, if there will be some of the questions. I recently redid, for example, Angular Materials Paginator in a reactive local way, and I can show that at the end if there will be any interest. And I'll be sharing some of the usages on the NgRx.io page. All right, so that was a reactive local state. And the last one is provided in root. So if we make a component store provided in root, it gets a little bit tricky here because most likely you're already working with some kind of global state that needs to be shared somewhere. If you're trying for the state that is shared anywhere, right? And you're trying into the component tree, and you start pushing it around further to the top, all the way to the top. That means it probably is some kind of global shared state. And then you might want to actually look into the NgRx store for it, not the component store. However, if that information is very, very, uniquely self-contained, then you can use it provided in root. But the first instinct, you probably should ask yourself, does it need to be provided in root or not, right? If it is provided, maybe it's globally shared, maybe there are other solutions how to work with it better. So that's why I have this exclamation mark here, so you can check that before you start implementing it. All right, so these are the 4 use cases. I'll be sharing these use cases in the NgRx.io page. I'm working on that as we speak. ComponentStore itself has been released yesterday. I was very excited about it. So it's there. It was released as part of NgRx version 10. So you can play around with it. Give me some feedback if you have any. And by the way, these 4 people were very crucial to its success as we were creating it. Kevin Yelko, he's my teammate at Firebase who originally implemented this version. Brandon Roberts and Tim DeShriver They are my fellow NgRx team members who spend a lot of time reviewing code, and we're going through the feedback and different iterations. So thanks a lot to them. Nicholas Jameson also provided a lot of feedback. He's a core RxJS team member and has one of the best blogs on RxJS. If you are not reading those, you're missing a ton. Definitely read it. I think it's ncjameson.com. So yeah, thanks a lot for those people. Official guide is published at the NgRx.io page. If you feel something is missing, let me know. Also, do be aware that I'm currently editing the usages page as well, and I'm trying to shape up the best practices kind of page as well, so people, with those type of questions have somewhere to look them up. One other interesting thing is we also created a Discord server for NgRx. So if anybody wants, have some questions and things like that, we opened up that. So please join us, and you can basically ask some of the questions there. It's all there. It's all available. We didn't go with Slack for this one to preserve history. Although I like, for example, threads and Slack better. Probably Telegram would be another option, but it's a little bit less popular in this part of the area where I am at in North America. All right, so that would be it for me. Thank you so much. If you have any questions, either live or in the Slido or in the chat, whatever you want, I'll be happy to answer them. Hopefully, it gives you a nicer overview of ComponentStore, what it does, how it works, and I can do some other demos as well. Thank you so much.
Thank you, Alex. Thank you for presentation. I'm already thinking about to try ComponentStore. And yes, we have some questions in Slido. So, and I remind you, if you want to raise your hand, we can start with voice questions. So Aristides, please.
Hey, Alex, thanks very much for this presentation. It was pretty awesome. Are there any schematics for the component store? Angular CLI schematics?
We added, I think, a way to add component store package schematic, but we didn't add anything else to it. It's fairly boilerplate free, I guess. So it's like creating a service. So there are schematics for this, or even VS Code snippets for creating a service. You'll just need to extend component store and then provide some kind of state for it. But other than that, no, there's nothing.
Right. Thanks very much.
Thank you.
Okay, so we are moving to Slido. And first question, I think, an interesting one about whether it's possible to use component store without NgRx store.
Oh yes, that's a good question. It's completely independent library, so you can use component store just by itself. I've seen some people who had a bad aftertaste after a global store. They think it's a complete waste of time. They think their services are better. If you have that opinion or that architectural approach, that's fine as well. You can just use component store without the global store. So if you really like your services with subjects, you should definitely look into this one, because it should help you organize things a little bit better. And yeah, you don't need a global NgRx for it. If you want to use some data from the global NgRx, there's no problem. You can do it. Select method takes multiple observables, so they combine data. Store.select from the global one could be just one of the observable inputs into it. So that's completely fine. Or you can use it with Aikita or anything else, really, what you want. They are solving different kind of problems. There are some areas where they overlap, especially for like a smaller to medium-sized applications. you might be okay with only, component store. But in the larger apps, you most likely would run into a case where you need both, or if your architecture is pure services and stuff like that, this would be also a good approach. In Firebase console, we using both, and we try to keep really globally shared things like permissions or URL router or anything like that, that's in a global store. And then when we get down to the details, then we will start using component store for smaller states.
Okay, thank you. Question from Valentin. Question from Valentin. Can Apollo Cache replace NgStore to manage with API data? And having NgRx plus Apollo together looks like an overhead.
Yeah, so NgRx and Apollo could be an overhead. I've never used Apollo other than just some toy examples for myself. So if you can control your backend architecture as well, feel free to use Apollo. If it works for you, that's great. I've seen some people mix those two together and still use either NgRx or the component. I haven't seen a component store, obviously, with Apollo. We just released it. For smaller things, maybe you can try it. But again, just think about this yourself. Like, would you have a service with some kind of state in there? If the answer is yes, if you would benefit from it, then maybe it's a good mix. Other than maybe not. Again, if Apollo works well for you, for your team, and you have full control of your backend APIs and stuff like that, maybe that's a better solution for you. I can't speak about it because for me, the APIs that we have, our team has very little say in it. Again, we're talking all over Google's different APIs and stuff like that. And especially, one team moved on to something else. Now we have to change the APIs and things like that. So we have to have that abstraction layer from the network or the service that we communicate for sure. And ideally have some kind of client-side models of even view models that are completely abstracted from all of that. So we can have still application and just readjust the DTO layer there.
Okay, good.
I see the question in the chat here.
Yeah.
Could you advise a good NgRx tutorial? I know one. Well, I'm actually teaching NgRx myself every so often. I don't have anything scheduled anytime soon. I'll probably be doing something but there is I know there's a popular one from Deborah Kurata on Pluralsight, and she's been working with Mike Ryan, who's our also fellow NgRx team member. I think I've heard good feedback about it. I haven't seen it myself. I have mine, and I think it has specific structure based on actual usage. Because just like all of you, I'm not a DevRel. I'm not a DevRel in terms of I build this stuff using these tools myself. I work every day. So I have to use it, and actually that usage drives how I teach it or drives how we structure some of the APIs as well. I also maintain NgRx within Google, so whenever I bring the newer version, I basically need to update like all 300 Angular applications to adjust this if it was backwards incompatible, something like that. I hope it's a long question, but I hope that answers. Well, a long answer, yeah.
Good. Next one from Dmitro. NgComponentStore versus our NgRx Angular state. What is the main difference? What is the right choice for production?
I knew that would be coming. All right. So first, before I answer anything, I'm definitely biased, right? So I feel original goals, I think, were also a little bit differently. I think our state was trying to solve the stateless problem, while for us, we handle a variety of different architectural use cases and patterns. Local UI, reactive UI state is one of them. And I think I actually would want to do the performance benchmark comparison, which I feel will be, well, I can't say. We'll see how that one goes. Size-wise, we are actually, let me see, where is this? Present now. Share. Let me find something to do. Clean up. Yeah, so I was doing some size comparison recently because I just was curious where we stand with this. And as you can see, we are 10 times smaller before minified, 3 times smaller after the gzip. It might not mean much. I think we have a very solid API, and I'm very happy how we separate the how from the actual usage. You could use ComponentStore directly in your component as well. Actually, I was just for fun, for demo purposes that I wanted to present in the usage section of NgRx pattern. There's a component called Paginator, so it's like Angular material component called Paginator. You probably all seen it before. Paginator. So it's basically this, right? This component, so we can do next pages, previous pages, items per list, and they all react, and they basically talk to the parent component about all of this. And I found this one in Angular because I wanted to have an example of local UI state. I found this in Angular, and it's this component. It's fairly big. Apparently, has a number of inputs. And overall, this component has all the business logic inside of it. Some of it is simple. Some of it is kind of calling other methods, and maybe I'm calling something else. So it was like 350 lines of code, maybe less because there's some, it starts from 100. So I want to re-implement it with ComponentStore, both as part of my component, actually, and when I push it outside, which is what I would recommend. As you can see, I re-implemented it like last night just to see that it works. Last page, first page, it's almost functional alternative. And moreover, I'm using their template. So I'm almost reusing everything template, but it's completely different code here. And it came up descriptive. I set the inputs using the set state, by the way. So this is one that I didn't show, but if you have access to the value that you want to push into the component store directly, you can just do the set state and provide that value. I might need to zoom in a little bit. And I'll close this one because it's clear. And I separated it clear to things that are updating. For example, set page index. And why I push it into the updater, because, well, it's used in a few places, right? I have a clear separation of effects. And things are becoming more reactive. For example, I'm pushing this one output here. It's when the page gets something changed and it needs to notify the parent component. For example, it sends this page event. And this is I didn't come up with this. This is what Paginator does. So, for example, if I do the next page, right, it sends the current page index, the previous page index, page size, and length. So whenever I change any of this, it changes in its things. And the way it's structured with the component store, it's all very reactive. There's only one place that emits this thing, here, page emit. But then it listens for other things. So you can be calling this multiple places. So it's a lot less. It's more structured. It's more focused on things. And then you have a view model that you select, that you actually push to the template and all of that. So this was fairly. It didn't take me too much, but I think now it's very compartmentalized. So it's like very specific things, and you don't have multiple things happening, and this is all very reactive. But then I then decided, hey, let's see it with the approach that I personally recommend, is not to provide a component store, but push this business logic outside. And here's what our Paginator component turned into. So I have a Paginator store that was doing almost all of the logic that we had before. And you have the input. I set the page index to the Paginator store. I have a length input. I set the length. I have page size options and stuff like that. I set the defaults. And when, changing sides, I'll let the store know. Change side, next page, previous page. And this becomes so much easier to read this component, so much easier to work. It's literally taking inputs and pushing the outputs. That's all it does. And then the store itself becomes also fairly understandable. And everything, is put together in its selectors are selecting, effects are causing some of the side effects and things like that. So I have those examples. I can share them later on somewhere. But yeah, this I wanted to basically touch on this. And this is the approach that I kind of actually recommend for a local view model for sure. I hope I don't have any other questions. I know it's a long answer, but I feel it's quite important.
Okay, thank you. Let's do a few more.
Mm-hmm.
Question from Anton: on which level of components we should use a global state instead of component state?
Yeah. So this is something that I try to describe again in the docs. I think of it this way: global state. So why? Okay, so there's a few things. Both ComponentStore and the global store, and even the push-based services with the subjects, they are push-based systems, right? So you have an interaction where, if it's a pull-based system, you call a method that goes to a HTTP client, calls it, brings you observable, you listen to observable. Like this is the pull-based, right? A push-based is different. Push-based is you let the service know that you need something, and then you listen to some other property that's usually an observable, and that gets updated when you get information. So it's interaction, right? So it's not directly, it's indirection, and this is the first level of indirection. And ComponentStore, global store, Akita, I think almost all of them have it. The benefit of it is quite clear. Now component doesn't need to know what changes that state. It just listens to that observable. If it changes, it shows up. In your cart icon, you just need to know how many cart items are in the cart, and you just show the number. You don't care if somebody clicked the add button or somebody clicked the delete button. All you care about that state of the application changed. So this is where this interaction really wins, right? And if you do need to know that, hey, I'm kind of curious how many cart items are there, you let the service know, and it would handle if there are other things already asking for the same information, and it would do the flattening strategy, race conditions, and all that stuff. So this is the first level of interaction, and it's quite an important one. The next level of interaction that what global NgRx store brings is the actions, right? What's the downside and upside? Well, the upside is that you can call that action, you can dispatch that action, and that action is handled could be by multiple effects, maybe different API calls. For example, my action is, hey, my main page opened, and it would ask for products, ask for ratings. So different effects are now triggered. Maybe some reducers are triggered as well. So you have an ability with one single message event into the system trigger multiple things, right? And this is a very powerful thing because right now with the, say, component store, you are explicitly calling either an effect or an updater from the component. Here, I'm calling, change page size, and this could. Oh, I'm not showing. Ha. I need the entire screen. Sorry about that. Here it is. So with this component, this change. Hold on, this one, change page size, right? And this one I'm calling a single specific thing. It's somewhere here. I can find it. I cannot find it. It's somewhere here. Yeah, here. So this is an effect. It does something. It calls a few updaters inside, right? Calculates, gets something. So it does a few things. But then I'm calling only one thing. With action, you can trigger multiple things that are completely independent. Like this is the beauty of action. You could start multiple things, and that could trickle down further. So but actions are yet another interaction. So you now have to see the cost of it. Is it beneficial for you to trigger multiple things and have a whole system as a whole to be to have a same state, or do I not need it? Is this the state that's needed only for this group of components, this subtree of components? Maybe then component store is a better answer there, right? Like permissions, they're all over. URL router, like, do I want to pass in the router activated thing and try to query params, or should I just figure it somewhere else and my component just reads the data of a current product, whatever current product is it by URL or by something else, doesn't matter. So this is where you start asking your questions and you have your answers as well. So I don't know. I don't think I have a better explanation than that. Well, I can talk about it for hours and hours, but in the interest of everybody's time, I think this answers it somewhat. I see a question in chat. For my app, I created my own store, which turned out to be similar to NgRx component store. Yeah? Would it be interesting to show you? Yeah, you can show me. I mean, definitely. And this is the problem is everybody has to reinvent this. Of course, because this is a push-based system, and this is the one that is supposed to kind of help replace it. It's maintained, it's tested thoroughly, it's used at multiple projects at Google already. I've been pushing to Google it sooner than public release. We've been using it, and right now it's used at 4 different Angular applications without me actually telling anybody, other than obviously Firebase console. And it's being already picked up. It's quite interesting how that thing spreads. But we've been using it for, since November of last year. Yes, APIs changed, and that was driving some of the API decisions, as well as the community feedback. So thank you for people who contribute with that feedback. That's very nice. But everybody has to reinvent one. And the interesting thing is ComponentStore is as a single file, and plus an operator. So if you go into the, here we go. See, I was going there as well. Modules, ComponentStore, source. It's basically a single service with like 300 lines of code. So it's a single thing. Plus it has debounce sync operator that actually I borrowed from Nicholas Jameson, but it's not exported, so it's internal to the system, so you don't have to worry about this one. So it is a fairly kind of simple, yet very powerful, and I'm sure that many of you wrote some variation of it here we're just trying to understand all of the problems and take them into account. So have more universal approach. So you have a tool that you can use. Yeah. Yeah, hopefully that answered.
Okay, good. And probably the last one, but not least. From architectural point of view, is it possible or is it good to use store in resolver?
Store in resolver. Like many answer, unfortunately, to almost a lot of the questions is it depends. But it depends, again, on many things. Personally, I try to not use resolver anywhere. Resolvers are, and again, I'm sure somebody say, oh, I use resolvers, they're great. They probably are if they work for you. Resolvers are UI blocking, right? So until the resolver is resolved, your UI, your components won't be rendered. And maybe it's good for some people say, hey, I actually don't want any of my UIs. But for me, I'd like to have my UIs to be a little bit more interactive. The worst, I mean, at least you can have a spinner on there, a component with a spinner, or you can have some other interesting approaches like ghost elements and stuff like that. So a little bit more interactivity, give at least some kind of scaffolding of your application. Don't block it. Let the components handle when they have data that don't have data so they can show it. So I'm not a big fan of resolvers. Moreover, we're trying not to use them at all. Guards is a different thing, but resolvers, not so much in general. So, yeah.
Okay, clear. Thank you very much.
Any other questions? If somebody wants to ask a question in Russian, whatever, it doesn't matter. Yeah, you're welcome. And I'm not can't promise, but I try to follow a little bit Angular Kiev Telegram. Sometimes I mute it unless I'm particularly tagged, because if I'm everywhere, I would have no work done. And I also every so often pay attention to the Angular RU Telegram as well. We had a few interesting discussions there over the weekend, which is fantastic. I love the discussion. As long as discussions are argumentative and productive, they're great. If it's opinions, I can't go with opinions. If somebody says, I don't like this because I don't like this, there's no arguments I can respond with. So if you say, I don't like this because how it handles this, that I can work with. And also, I don't try to pretend that I have answers for all the questions as well. Obviously, all learning and discovering new things. Things are evolving, and I'm sure that even with the component store, there probably would be some additions and stuff like that. They'll later change, maybe even slightly change API or something like that. At the moment, I'm very happy with the APIs and things like that. I didn't tell all the secrets of it. I'll try to explain them, some of the like usages and all that. Yeah, hope it was very informative.